Good afternoon, all of you. In the previous lecture, I am discussed about the Ylide, introduction of Ylide, types of Ylide, phosphorus Ylide, and the preparation of phosphorus Ylide. Today, I am going to deliver lecture on types of phosphorus Ylide. So basically, on the basis of structure and stability, on the basis of structure and stability, phosphorus Ylide are of two types. First one is stabilized phosphorus Ylide and second one is unstabilized phosphorus Ylide. These are the two types of phosphorus Ylide: stabilized phosphorus Ylide and unstabilized phosphorus Ylide. These both the types are dependent upon structure and stability. When we see the structure of phosphorus Ylide, look here, PH3, P positive, CH2 negative. This is the structure of phosphorus Ylide. When we observe it, the stability of this phosphorus Ylide are depend upon the group which is attached to this carbon atom. So here only hydrogen will be attached. So I am here attached. Suppose X group. Okay. So the stability of this phosphorus Ylide will depend upon this X group. Means the stability of any Ylide will be depend upon the group which is attached to the nucleophilic carbon atom of phosphorus Ylide. Here this carbon acts as a nucleophile and it is attached with the X group. So the stability will be depend upon this X group. And on the basis of stability and structure, phosphorus Ylide are of two types: stabilized phosphorus Ylide and unstabilized phosphorus Ylide. We will see both the types one by one. Firstly, we will see stabilized phosphorus Ylide. When we see the title stabilized phosphorus Ylide, there are two questions will be arising in your mind. The first question is, what is stabilized phosphorus Ylide? How to define it? And the second question will be arising in your mind, how to prepare it. So here I am explaining the answer of both the question one by one. Let's see here. I am right here the general structure of phosphorus Ylide. P positive singly bonded with carbon negative. Okay, this is the general orientation of phosphorus Ylide. Here I am taken hydrogen and here taken C2 double bond. C double bond O R, and they are taken one phenyl group, here one phenyl group, and here one phenyl group. This is the structure of phosphorus ylide. We know that. When we observe this structure, here the carbon have a negative charge. It means it acts as a nucleophile, and we know that nucleophile are the electron-rich species. And this carbon atom is attached to the one C double bond O single bond OR group. This is ester group. And it is also called as electron withdrawing group. Electron withdrawing group. So what will happen here? The electronic withdrawing group attract the electronic clouds. Attract the electronic clouds towards itself from neighboring group, due to which the charge of carbon atom, the negative charge of carbon atom is stabilized. Means it is this carbon atom becomes stable due to electron withdrawing group. So such type of phosphorus ylide in which the nucleophilic carbon atom is stabilized with electron withdrawing group by the resonance or inductive effect are called as stabilized phosphorus ylide. This is the explanation. Now how to define stabilized phosphorus ylide? Listen. When nucleophilic carbon atom, this is the nucleophilic carbon atom, okay? When nucleophilic carbon atom in a phosphorus ylide is attached with the electron withdrawing group, when nucleophilic carbon atom in phosphorus ylide is attached with the electron withdrawing group by resonance or inductive effect, then it is called as stabilized phosphorus ylide. Okay, so this is the type of stabilized phosphorus ylide. Here we can also use various type of electronic withdrawing group. And we know that this phosphorus ylide is stable, but it is highly unreactive. Because of stability is inversely proportional to the reactivity. So it is stabilized but highly reactive. So this is the definition and explanation of stabilized phosphorus ylide. How to define stabilized phosphorus ylide? When nucleophilic carbon atom in phosphorus ylide is attached with the electron withdrawing group by the resonance or inductive effect, then this type of phosphorus ylide are called as stabilized phosphorus ylide. So this is the answer of first question. Now the second question will be arising in your mind, how to prepare it. Look here and prepare the stabilized phosphorus ylide. Preparation. We know that the phosphorus ylide will be prepared into two steps. The first step is formation of salt, and the second step is formation of product. We'll see both one by one. Firstly, formation of salt. In the formation of salt, we have two reactors. First one is triphenyl phosphine and another is alkyl halide. So here I am taken triphenyl phosphine. This is the structure of triphenyl phosphine. Is interact with alkyl halide. Okay. Here I am taken this type of alkyl halide. So in the first step of formation of stabilized phosphorus ylide, the triphenyl phosphine is interact with alkyl halide. So this reaction generally occurs into SN2 type. What will be happen here? The lone pair of phosphorus act as a nucleophile. It attack on a carbon of alkyl halide. Simultaneously, the bromine will be removed and we will get this type of intermediate PH3 P positive single bond CH2 single bond C double bond O OH, and the removing leaving group present here as it is. So this is the first step intermediate. It is generally called as phosphonium salt. So in the second step of preparation of stabilized phosphorus ylide, the second step of preparation of stabilized phosphorus ylide is formation of final product. So in the second step of formation of stabilized phosphorus ylide, the newly formed phosphonium salt is treated with a strong base. So here I am taken N-butyl lithium as a strong base. Generally N-butyl lithium represented like that. So here I am taken N-butyl lithium as a strong base. We know that if the N-butyl lithium undergoes heterological bond kill weight, so then the N-butyl bear negative charge and lithium bear positive charge. So what will be happen here? The n-butyl lithium extract one proton from that carbon atom. Due to the loss of one proton from here, the carbon become negative charge species, and we will get our desired product like that. PH3 P positive single bond CH. Here one hydrogen will be removed from n-butyl, so only one hydrogen will be present here, and the carbon become negative charge species. Single bond C, double bond O, OH. This is the final product, phosphorus ylide. And the byproduct is n-butyl and ylide. When we observe the final product, phosphorus ylide, here we can understand the nucleophilic carbon atom of phosphorus ylide is attached with the electron withdrawing group. This is the carboxylic group. It is electron withdrawing group. So due to which this carbon atom is stabilized. This type of phosphorus ylide is called as stabilized phosphorus ylide. So this is the types of stabilized phosphorus ylide. So this is all about definition, introduction and preparation of stabilized phosphorus ylide. Okay. Now the second type of phosphorus ylide is unstabilized phosphorus ylide. The second type of phosphorus ylide, unstabilized phosphorus ylide. And we see the title, headline. There are two questions will be arise in your mind. The first is, what is unstabilized phosphorus ylide? And second is, how to prepare. We will see both one by one. Now see here, I am write a general orientation of phosphorus ylide. P positive singly bonded with C negative. The carbon have 4 valency, 1, 2, 3, 4, and if the phosphorus have positive charge, then it have 4 valency, 1, 2, 3, 4. Okay. Here I am taken hydrogen and here taken C2H5. Here one phenyl group, here one phenyl group, here one phenyl group. Okay, so this is the general structure of phosphorus ylide. When we observe this structure, we can understand that the carbon atom of phosphorus ylide have a negative charge. Okay, it means it acts as a nucleophile. It is electron rich species and directly bonded with or directly adhered with C2H5 group. C2H5 group. We know that all the alkyl group are electron donating group. So this C2H5 group is electron donating group. So what will be happen here? The electronic donating group donate the electronic clouds to the nucleophilic carbon atom of phosphorus ylide. So here this is the nucleophilic carbon atom phosphorus ylide. So this donating group donate the electronic cloud to the nucleophilic carbon atom. Here carbon already electron rich species, and also C2H5 electronic donating group donate their electronic cloud, due to which the negative charge of the carbon will be increases, and the carbon become highly unstable. So such type of phosphorus ylide in which the negative charge of the carbon ion, a nucleophile, is increases by the electron donating group with resonance or inductive effect, called as unstabilized phosphorus ylide. So this is the example of unstabilized phosphorus ylide. Okay. So how to define it? Now listen. When nucleophilic carbon atom in phosphorus ylide, is attached with the electron donating group, here C2H5 is an electron donating group, then by resonance or inductive effect is called as unstabilized phosphorus ylide. When nucleophilic carbon atom of phosphorus ylide is attached with the electron donating group by resonance and inductive effect, then it is called as unstabilized phosphorus ylide. This is the definition and simple explanation of unstabilized phosphorus ylide, and this is our answer of first question. Now the second question will be in your mind, how to prepare it. So simply we know that phosphorus ylide are prepared into two steps. First one is formation of salt, and second one is formation of final product. We will see here. Preparation of unstable phosphorus ylide. So preparation of unstabilized phosphorus ylide consists of two steps. First one is formation of salt. Okay, in the formation of salt, triphenylphosphine is interact with any alkyl halide which contain electron donating group. Now look here, I am right. Triphenylphosphine as the first reactant, and BrCH2 C5H11. So C5H11 are the alkyl group, and it So in the first step of formation of unstabilized phosphorus ylide, the lone pair of phosphorus act as a nucleophile and it attack on this carbon atom. Simultaneously the bromine will be removed here and we will get intermediate product salt like that. PPH3, P positive, single bond CH2, C5H11. Okay, this is the corresponding sort of triphene phosphate and alkyl halide. We know that the salt in which the carbon of adjacent non-metallic species have a more acidic hydrogen. So here two hydrogen will become more acidic and it will be easily available to remove. So in the second step, formation of product, we can use the newly formed salt that interact with any strong base. So I am here taken N-butyl lithium. Okay, the N-butyl lithium is a strong base. So in this reaction, firstly the N-butyl lithium undergoes electrolytical bond cleavage and butene bear negative charge and lithium bear positive charge. Because of carbon have a more electronegativity than lithium, so both the electrons shifted toward carbon and carbon become negative charge species and lithium become positive charge species. So here N-butyl extract one proton from this carbon atom and converted into N-butane. Also the bromine is interacted with this positive charge lithium and converted into Li Br. And finally we will get our final product, phosphorus ylide. Here PH3P positive, single bond CH negative, C5H11. Okay, one hydrogen will be removed here, so the carbon bear negative charge, and this is our final product, phosphorus ylide. When we see the structure here, the carbon or nucleophilic carbon is attached with the electron donating group. C2H5 is an alkyl group and is donating group, due to which the carbon contains charge, negative charge become highly unstable. Hence it is called as unstabilized phosphorus ylide. So in this way we can easily prepare unstabilized phosphorus ylide. In the preparation of unstabilized phosphorus ylide, or we can use different type of electron donating group, and in the preparation of phosphorus ylide, stabilized phosphorus ylide, we can also use different type of electron withdrawing group. Lastly, I am telling you one point. We know that the stability is inversely proportional to the reactivity. Stability is inversely proportional to the reactivity. Okay. If the phosphorus ylide is stable, then it is less reactive. If the phosphorus ylide is unstable, then it is highly reactive. So this is all about the preparation, definition and explanation of second type of phosphorus ylide, unstabilized phosphorus ylide. I hope you will be understand better. If you have any problem regarding to this topic, you can ask me personally on WhatsApp. Okay, so here I am stop.